you're probably thinking, significant figures are not significant in my life. I don't really care if a number is significant or not. And you'll say, why are we ever going to use this? Or when am I ever going to use this? I don't want to look at numbers all day and count their significant figures. Oh, actually, this is a good thing. Like, you really like significant figures. It's used to help in rounding after calculation. This is a good thing. And again, like in your previous science classes, you do calculations and they might have said, oh, I don't know, just round everything to 2 decimal spots or something like that. Now, again, we are more sophisticated, and the amount of figures that we report in our final answer is dependent on the numbers that we're using in our calculation. There are 2 rules. One rule for multiplying and dividing. One rule for adding and subtracting. This is a good thing. I promise you're going to like this. Okay, so let's do the multiplication division rule first. And to be honest with you, this is the one that you use most often. Okay, so let's say we're doing a density calculation. 2.05 grams divided by 0.67 milliliters. I plug this in my calculator, and here's what I get. My calculator tells me, ooh, garbage. There's a number that goes all the way across the screen. It's like 3.059701493 grams per milliliter, of course. Of course, I'm going to put a unit behind my number. This is science, not math. I don't want to write all that garbage. And if you think about it, again, in science, a number means something. It should be something that I can go and reproduce in the lab. I can't measure a number out to, what, 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal spots? I can't do that in the lab. That's ridiculous. I mean, this would be tenths, hundredths, thousandth, 10,000, 100,000, millionth. This is like measuring down to a billionth of a unit. We can't do that in our rinky-dink lab back here. That's crazy. So it's not reasonable to report that as my final answer. So here's the rule. When you multiply or divide, you plug it in your calculator. Then you look at the 2 numbers that were part of your calculation, or maybe it's more than 2. You're going to round your final answer to whatever piece of data had the lowest amount of sig figs. Okay, so I had 2.05. That's 3 significant figures. 0.67. Remember, that's only 2. Because this 0 in the front is a leading 0, a placeholder. It's only 2 significant figures. So guess what? You plug this in your calculator and you just round it to whatever piece of data had less significant figures. So in this case, we're going to round it to 2. So I would just leave my final answer as 3.1 grams per milliliter. This 5 would round it up to 1. That's it. This is something that you're just going to do right off your calculator. You're not even going to think about it. You're going to plug the numbers in, you're going to look at the data, and automatically in your head, you're just going to write down on paper the least amount of significant figures. It's a beautiful thing. So for example, there are 4 example problems down at the bottom here. It's so easy. You plug this in your calculator, 3.098 times 2.90. And here's where you have to count the significant figures. And again, you'll get really good at this. 3.098 has a trapped 0, but it's fine. It's still 4 significant figures. 2.90 has 3. There's a 0 at the end, but there is a decimal spot. All 3 count. So in my calculator, I get a whole bunch of junk. I'm just going to write down the first 3 figures. That's all I have to write on my paper. That's my final answer. Isn't it beautiful? So right away in number 2, I've got 4 sig figs times 4 sig figs. I'm going to plug that in my calculator, and I'm going to get a whole bunch of garbage. I only have to leave the first 4 figures. It's nice. It's a good thing. This works with division the exact same way. You plug the numbers in your calculator, and again, you're probably going to get a calculator screen full of figures. You just round it to whatever piece of data had less significant figures to start with. So you got 8.082, that's 4, divided by 4.23, which is 3. You just leave the first 3 figures off your calculator, that's it. And it doesn't matter where those figures fall. So for example, like in number 4, 1, 2, 3, 4, 5, 6 significant figures, divided by 3 significant figures. I just leave the first 3. It's okay that it's like 11.9, which is a little different than either piece of data. The decimal spot falls in a different place. That's fine. You just leave the first 3 figures and that's it. You'll use this a lot. We'll do a ton of multiplying and dividing. And again, it's just going to be something that is second nature. You're not even going to have to think about it anymore. We'll just automatically write down the answer, leaving the amount of significant figures that matches the lowest amount of sig figs in the data that you multiplied or divided. And so again, if you'd like to, you could pause the video at this point, try plugging these 4 into your calculator so that you can kind of see, oh yeah, the number was a lot larger. There's a bunch of garbage on the calculator. But that is how I properly round my calculations. The adding and subtracting rule is a little bit different. And to be honest with you, you're not going to use this one as often. You would round your answer to the lowest number of decimal spots. A little different. Multiplying and dividing, you plug it all in your calculator, and you round it to the piece of data that had the least amount of total significant figures. Now I'm going to plug this in my calculator, and I'm going to round it to whatever number has the least amount of decimal places. So for example, if I look at this list, I'm going to add 10.23 plus 6.1 plus 0.025 plus 16.22. You can plug that all in your calculator, but when I round and when I report my final answer, I'm just going to leave whatever had the lowest amount of decimal spots, not total significant figures. So in this case, I'm going to leave 1 decimal spot. My calculator gives me 32.575, and these must all be grams. But I'm going to round that to just 32.6. 32.6. You just round it to whatever piece of data has less decimal spots. Oh. Okay, now let me tell you one of the reasons why you won't use this as often. If somebody really had data like this, they must have used different balances. So they're adding these masses, but their electronic balance must have had like different amounts of decimal spots. In the lab, you probably won't need to worry about this. All of our electronic balances measure to 2 decimal places. So there are times when you might add or subtract masses, but you probably use the exact same electronic balance. So they'd all have the same amount of decimal spots. Or let's say you were subtracting final volume and initial volume. As long as you used the same graduated cylinder, those volume measurements would have the same amount of decimal spots. They might not have the same amount of sig figs, but they should have the same amount of decimal places. And then you wouldn't really have to worry about this a whole lot. It does happen, though. I mean, maybe you want to add masses or you want to add volumes or something like that, and they were measured with different measuring tools. Then we plug them in our calculator, and we're just rounding to whatever piece of data has less decimal spots. So again, here are some examples down at the bottom. In number 1, if you have a whole number, I guess like in number 1 and number 4, then you just plug it in your calculator and you leave it to the nearest whole number. Now in number 1, I wouldn't go crazy if you put the decimal spot or not. As long as you didn't have anything after the decimal spot. We just want to round it to the nearest whole number. Kind of the same thing with number 4. Subtracting 0.07 is actually kind of insignificant. I'm going to leave the same number. If I subtract, I get 986.93, but if I round that to the nearest whole number, I'm going to round it back to 987. Again, then in the middle, don't get tripped up on something like 2. Adding and subtracting goes by the lowest number of decimal spots. So I'm just going to leave 1 decimal spot. Even that first number, 0.0075, that's considered 4 decimal places. And I know you're probably thinking, ooh, 2 sig figs. And you would be thinking correctly. But with adding and subtracting, we're looking for the lower amount of decimal spots. So we're going to round it to 1. And number 3, we're going to plug it in our calculator. And we're going to leave it to 2 decimal spots. So this might be another good place too. Pause the video, try plugging some of these in your calculator so you can see the original number, and then I rounded it to the piece of data that had the least amount of decimal spots for adding and subtracting. Multiplication, division, lowest amount of total sig figs.